Yeah. You guys are seeing my screen, right?
Yes, sir.
Yeah. Fine. Thank you. So in the last session, we have seen up to supports. Okay, we have seen up to supports. Now let's continue this one. So after giving supports, we need to give loads. Okay, so the next one is loads. So yesterday we have discussed what are the loads coming onto the structure. So if you see this, the load number 1 is seismic in positive direction. So before going to the seismic loads, you have to define a seismic definition. Okay, so how you will define a seismic definition? So in that, for that we have to, because we are doing it is ASCE design, we are going to apply seismic by the reference of IBC, International Building Code. Okay, and that too we are going to design the loads according to ASCE 710. Okay, whatever the values we have done, seismic calculations, wind calculations we have seen, right? What we have done, design wind pressure calculation as per ASCE 710. Okay, so according to the 710, we have to apply loads. Okay, for this MBMA 2012 I am going to use to apply loads, and for seismic I am going to use IBC, International Building Code. Okay, there is no direct provision for seismic. All the American codes will be acceptable with IBC, International Building Code. Okay, so that first I have to define IBC. So for that I'm defining, sorry. So okay, all this is syntax. I'll let you know how to do without syntax also. I'll let you know. Don't worry about all these things. Define IBC 2012. Since we are using here 2010 edition ASCE 710, so the after that 2010 we have to use the IBC code. So I am taking IBC 2012 because it is coming after 2010 the edition. Okay, and the next thing, for define, just someone is disturbing me. So after defining IBC, we have to give the seismic parameters. Seismic parameters means we have seen the last time, right? SS, S1, and R, and something soil class, and long time period. All of you guys have revised all these things. If you observe here, if you go to ASCE seismic, we have seen R value, importance factor value, SS, where is that SS? SS, S1, all these things we have seen, right? So all these are called simply seismic parameters. So we have to give seismic parameters in this session. So first one, SS. So what is the SS value here? SS last time, for example, we have taken SS value. What is that? 0.057, right? 0.057. And the next S1. What is the S1 value in this example? Just I'm again requesting you, all the people, while coming to the session, please mute yourself so that other people will not disturb. Okay. Okay, guys. Thank you. SS is 0.057 in our example, and S1 is 0.032. All the guys, you remember all these things, right? We have seen in the seismic calculations. And SS, S1, and then Rx. Rx is nothing but what is meant by R? Response modification factor in X direction and in Z direction. Actually, Z direction no need, but as a formality, we need to give Rz. This is 3.5 Rx and Rz. Both are 3.5. And then S class. S class means soil class. Okay. If there is no predefined soil class, actually there are certain classes A, B, C, D, E, and F, something like that. Okay. What is A indicates hard rock, and B indicates normal rock, C indicates soft rock, D is medium stiff soil, and E is loose soil. Like that, they have American code have defined the soil class. So if the soil class of the particular location is not known, we can take soil class 4, nothing but soil class D, that is medium stiff soil. That is not too loose soil, that is not too hard soil. So we have to take on an average soil class 4, soil class D, nothing but soil class 4 in the sense A, B, C, D. D indicates 4. Okay. Soil class 4 indicates soil class D. And then last one remain TL, long time period, 12 seconds. And in that I have one more thing I missed. Importance factor. Yeah. SS S1 I. What is the importance factor value? I 1.0. So all these things, don't confuse all these things. All these things we have seen in our example. In the seismic calculation session, we have seen all these things. I, R, and SS, S1, all these things we have seen, right? So those things only. If you see TL12, why I have given TL12 from the graph we have taken at the time. Whether you guys remember or not, please go through the revisor sessions. So recorded sessions. So you can get them. So TL12 seconds we have seen in our example. That is the value TL12 I have given here. So here we have defined seismic code. Now seismic weight you have to give. Okay, seismic weight we have seen, right? Seismic weight. So there is that seismic weight. Yeah, effective seismic weight W, dead load plus some portion of live load into tributary area. Because there is no factor for or 25% or 50%, there is nothing like that for live load, roof live load. In the ASCE 7 code, we have taken 0, because if you go through seismic weight in the code class 12.7.2, in that you can observe dead load into tributary area. Directly they have given for the roof. Okay, because they did not take any value for live load. So that's why dead load plus 0 into tributary area we have taken. But practically most of the companies do 25% of live load. Dead load plus 25% of live load into tributary area. Tributary area we will see. What is tributary area? Width into tributary length. So that is called tributary area. In this session, first of all, anything we are giving weights, you have to define self weight also, because self weight also impacts seismic. Okay, so self weight 1, and then how to calculate seismic weight. So okay, I'm mentioning all these things in the commented lines here. You can ask if you have any doubt. Roof seismic weight. So what is the formula? Actually we have dead load plus 0 into live load into tributary, right? This is the actual formula we will do, but most of the companies for safety purpose, they will allow 25% of the live load. 25% means 0.25, like that they will take. Okay, no need to give width here, because we are doing 2D frame. In that width will be directly applied here. So we need to give tributary length only. So, okay, all of you guys remember what is tributary, right? So in yesterday's example, we have seen. So for that, for the grid line 8, what is the tributary value? 7.5. Okay, width no need to give. Width directly we have given geometry, right? Along with we have provided a geometry. So we have along the width we have provided geometry. So no need to give this width now, because we have mentioned here tributary area. Tributary area means tributary length into width. Okay, so width already we have given in the geometry. So you need to give tributary length only. What is the tributary length? 7.5 plus 7.5 divided by 2, that is 7.5. Like that we will do. Okay, so I am applying this formula. What is the dead load in our example? Yeah, suppose length or widths we have changed, right? So don't bother about all these things. Dead load and live load, this is an example, sample example. That's why I'm taking rough values to explain you. So dead load is 0.3. Okay, so dead load is 0.3 plus 25%, nothing but 0.25 into live load 0.6. All these things, what values we have taken in example, that is the things I am taking here in the practical session. Except length and width and tributary, only geometry has been changed. The loads what we have taken in our example, those are the same loads I am taking here. Okay, so dead load plus 0.25 into live load into what is the tributary length here? We are doing tributary of 7.5, because the adjacent tributaries, if you see in the plan here, 7.5 plus 7.5 divided by 2, that is 7.5 average load width of the grid line 8. So that is the value I am taking here. So 7.5. I am not giving width here. Don't confuse, because width along the geometry we have given width. This is 2D frame. We have given width in the geometry. So that is why I am not applying the width here. Okay. I'm not applying the width here because we have given width in this direction. We have provided in the geometry itself. It will calculate directly what is the width value. So that's why I'm not giving here. So now calculate this one. 0.3 plus 0.25 into, actually 0.25 is not there in our code, but companies will follow for some safety precautions only. Okay, nothing change will be there. Nothing change will be there. Just 25% of live load. Live load is just 0.6, but there will be nothing change if you give 25% extra. Okay, so dead load plus 0.25 into live load into 7.5. So you guys calculated anything? 3.375. I got it. Right? So the value I got here is 3.375. So if you observe, this will be in, sorry, kilonewton per meter. Kilonewton per meter. Okay, because we are not applying, actually what is the units for this? If you observe in our example, kilonewton per meter square. Live load also kilonewton per meter square. These are aerial loads. Okay, so kilonewton per meter square into tributary length, kilonewton per meter square into meter. So what you got is UDL here. So okay, so you have to apply this UDL on the rafters, because seismic forces will apply at some particular level from the ground. So that's why we have to apply the seismic forces along these rafters only. Because dead load and live load, if you see here, dead load and live load we have considered to calculate seismic weight. Those dead loads and live loads will be acting on the rafters only, not will be on column. They will distribute on the column, but they will not act directly on the column. That is why we have to apply seismic weight on the rafters only. So what is the numbers of rafters? 6 to 23. So for that we need one more command, member. So be careful that all the commands should be in capital letters only. Generally we will give, okay, member weight, members, all these can be taken as members. We are giving seismic weight here. So